Okay, this is Chapter 3, Section 3, Algebra 2. We are going to be solving linear systems still, but we're going to solve linear systems that are inequalities. So we're going to combine what we did last chapter, which is graphing individual inequalities. That means shading, remember. You see that little symbol, you've got to remember to shade. But we're going to combine them and get a solution area that overlaps these two. So the first thing we're going to do is draw the graph of the first inequality. Okay, remember that we use a solid line when it's equal to. In this case, our y-intercept's 2, our slope is 1, so we graph that line right here, and we say everything less than that is below, so we shade everything down in here. My line is solid. It's kind of hard to see, but it's solid, and we shade that region. The next equation we're going to graph on the next slide is x greater than 1. Remember, x equals 1 means a vertical line at x equals 1. And this time we make it dashed because it's not less than or equal or greater than or equal to, it's just greater than. Since x is greater than 1, we shade on the right-hand side. Okay, this is kind of review. Well, what happens when we combine these two onto the same graph is we come up with an overlap region that includes this purple part and this other orange part. In other words, it's the dark purple area. This dark purple area is your solution. You can check it by choosing any point that lies in this region, plugging it into both equations. We're trying 2, 2. If you look really close, every 5 lines is worth 1 point. So this is 1 and this is 2. So 2, 2 would be right here where my arrow is pointing. That's the point that we're choosing to try. So we're going to try it in the first equation down here. We're going to try it in the first equation, and we're going to get is 2 question mark less than 2 plus 2, and the answer is yes. Is 2 greater than 1, and the answer is yes. So we know that we graphed it on the correct side. This next example is similar, so I'm calling it 1b. We're going to graph two inequalities that look like this. Starting with the first one, we see it's already in mx plus b form, so we're going to graph the 1 on the y-axis, or the y-intercept, and we're going to go down 1 over 1 from here. So my line is a dotted line, and I shade above there because it's greater than. The next line that I'm going to graph is a y line. It's y equals 2. Y equals 2, remember, is a horizontal line that goes through the point y equals 2. It's going to be solid, and I'm going to shade everything below that line because it's less than. You can clearly see that when I graph these two like this, my overlapping area or solution area is this dark pink or purple part right here. The checkpoint that I'm going to choose, since this is 0 and this is 1, I always like to pick easy ones, and 0, 0 does not lie in my solution, so I need to pick one that does lie in my solution. I'm going to choose 1, 1 because it's the point right here. Plugging in 1 into this equation, is 1 greater than negative 1 plus 1, or greater than 0? Yes. Is 1 less than or equal to 2? Yes. So we know that we've graphed the correct solution. This next example, example 2, involves 4 inequalities, and it asks you, or it tells you that it's going to create a geometric figure, and it wants you to tell them what kind of geometric figure it is. So we're having a geometry review here, which will be a great ACT and even the PSAT, which you guys are taking soon, review. So we're going to graph all 4 of these inequalities. The first one is the only one that's at a diagonal. The rest of these 3 are all horizontal or vertical lines. So when we graph them, we're going to graph the first one using a solid line. Remember, less than is below. 2 is my y-intercept. Up 1, right 2. Up 1, right 2. Up 1, right 2. The next equation happens at y equals negative 2, so it's going to happen down here. And it's everything greater than that, so that's the light green area. And you can see our solution so far is this darker greenish blue color here in the middle. Graphing x equals 3 will be over here, right here. And we're going to shade everything to the left of that since it's less than. And finally, we're going to graph x greater than or equal to -2, which happens over here. Sorry, over here, when we graph that, you can see I have this final solution area that's in the dark brown here. I can trace it now for you. And you can see that the geometric shape it makes, let's have a little review here. Whenever you have two parallel sides and two that aren't parallel, like these two, it's called a trapezoid. So the answer to this would be this graph, and then the final answer would be a trapezoid. Let's try one more of these. We're going to graph 3 inequalities this time. Hopefully you're probably figuring out what shape we're going to get. We're first going to graph the line 2x plus 1, and we're going to shade below since it's less than. So we go to y-intercept of 1, up 2 over 1, up 2 over 1, up 2 over 1. Graph the line, shade below. The next line is -x plus 1. We're going to go up to 1. We're going to go down 1 over 1, down 1 over 1. Graph that line, but this time we're going to shade above since it's greater than. You can see our solution is in this darker greenish blue area here. And we're finally going to graph the line x equals 3. Shading below that line, we're going to go over to x equals 3, make a vertical line. Sorry, not below, left. We're going to shade everything left since it's less than. And you can clearly see that the answer to this geometric shape is a triangle, and that's the final answer. Okay, now we're going to do a quick word problem similar to what we did in the 3-1, 3-2 video with word problems. This time we're going to have some information about painting and how she wants to keep her cost, how much she wants to make, excuse me. So we're going to write 2 inequalities here. So it first tells us that she wants to paint no more than 70 plates. Well, we have 2 different types of plates. Remember, this is a systems chapter, so we're going to have an x and a y. We're going to have equations that represent that x and that y, and she doesn't want to paint any more than 70, so we're going to say x plus y less than or equal to 70. All I've done is taken that first equation. Haven't done anything else. The second equation says it costs her at least $50 plus 2 per item to produce red plates. So the red plate cost is going to be 50 plus 2x, x would be the number of red plates, and $3 per gold plate. Y would be the gold plate. So we're going to make another equation, 50 plus 2x plus 3y. Then it says she wants to spend no more than $215. Since she doesn't want to spend more than that, that means we need to set up our equation less than or equal to 215. So now we have our 2 inequalities. We're going to simplify them a little bit, and we're going to graph the line x plus y equals 70. This line is, we'll go over this in class tomorrow. We're going to subtract 50 from both sides and graph that line. And we're also going to remember that we're going to always be positive. She's not going to have negative number of red plates or negative number of gold plates. So the boundary or the area for this one is going to be this gray area here. And I will go ahead and trace it with my a blue outer edge, and you'll see that this area is the final solution for those 2 inequalities. We're going to plug in a value that falls into these. So we're choosing 20, 20 because that's easy to work with and it clearly falls into the shaded area. Plugging 20 into this equation gives us 40 is less than 70. Plugging 20 into this equation gives me 150, which is clearly less than 215. Okay, I will see you tomorrow. We will practice graphing with our pencil, and I will show you how to shade when you don't have different colors. We'll practice in class tomorrow. See you then.